Today's goal of this lecture, today I will solve how we will solve easily differentiability of functions of several variables. At first I will see method, then I will see some question. This is today's goal of this lecture. First I will see how we will check differentiability of function of several variables. Let f be a function from S to R be a function where S be subset of R2. Suppose alpha be any point in the interior point, then fxy is said to be differentiable at AB if f of a plus a is b plus k minus f of b equal to a is fx ab plus k fy ab plus a is phi 1 a is k plus k phi 2 a is k, where obviously limit a is k tends to 0 phi 1 a is k and limit a is k tends to 0 phi 2 a is k equal to 0. That imply since phi 1 a is k and phi 2 a is k, as a is k tends to 0 0 is goes to 0, so that from this expression we can write this as f of a plus a is b plus k minus f of ab minus a is fx minus k a is fx at the point ab minus k fy at the point ab equal to a is phi 1 a is k plus k phi 2 a is k and divided by square root of a square plus k square both sides. Then apply limit a is k tends to 0 0 f of a plus a is comma b plus k minus f of ab minus a is fx ab minus k fy ab equal to limit a is k tends to 0 0 a is phi 1 a is k divided by square root of a square plus k phi 2 a is k divided by square root of a square plus k square. Since phi 1 a is k and phi 2 a is k, as limit a is k tends to 0 0 is equal to 0, so this value is equal to 0. That imply limit a is k tends to 0 0 f of a plus a is b plus k minus f of ab minus a is f of x ab minus k f of y ab divided by square root of a square plus k square equal to 0. If this equal to 0, then we can tell f is differentiable at the point ab. This is one method to find differentiability. In my previous video I had seen f which is defined from the open set U which is subset of Rn to Rm and a be interior point of U. Then f is differentiable at the point A if there exists one unique linear transformation T from Rn to Rm which satisfying limit h tends to 0 norm f of a plus a is minus f of a is minus t of a is divided by norm is this norm equal to 0. In my previous video I had seen this is the definition of differentiability in functional several variable. Now I will solve some question. First question, f of xy equal to xy times x square minus y square divided by x square plus y square. When xy not equal to 0 0, then this is the value, and when xy equal to 0, then the value is 0. Find the differentiability. At first, check partial derivative fx at the point 0 0. This value is limit h tends to 0 f of a is 0 minus f of 0 0 divided by a, so this value would be 0. Similarly, f of y at the point 0 0 is value is equal to 0. Then for differentiability, here I will use these rules. Here the point is 0 0, we have to check the differentiability at the point 0 0. So the rules is f of a is k minus f of 0 0 equal to a is fx at the point 0 0 plus a is fy at the point 0 0 plus a is phi 1 plus k phi 2. Okay, and here I have got fx and fy, this value is 0 0. Therefore f of a is k equal to a is k times x square minus y square divided by x square plus y square equal to a is phi 1 plus a is phi 2. Here f of a is k, so this value would be a square minus k square, a square plus k square. Therefore that imply a is times a square k divided by a square plus k square plus k times minus a is k square divided by a square plus k square equal to a is phi 1 plus k phi 2, where phi 1 a is k equal to a square k divided by a square plus k square and phi 2 a is k equal to minus a is k square divided by a square plus k square, and limit a is k tends to 0, a is k tends to 0 0, a is square times k divided by a square plus k square, this value is equal to 0. Because as limit k tends to 0, since this is a bounded function, this part is bounded, so obviously limit k goes to 0, a square goes to 0. Similarly, this is equal to phi 1, phi 2 equal to limit a is k goes to 0 0 minus a is k square divided by a square plus k square, this value is also equal to 0. So phi 2 a is k also equal to 0. So this value is since equal to 0, so the function is differentiable at the point f is differentiable at 0 0. I hope my all viewers have understood the method. Since phi 1 phi 2 both limit as a k tends to 0 0 is 0 0, so function is differentiable. We can use this method also. By this method we can tell if this value is equal to 0, then we can tell function is differentiable at the point, here the point is 0 0, function is differentiable at the point 0 0. Limit a k tends to 0 0, f of 0 plus a comma 0 plus k minus f of 0 0 minus a is fx 0 0 minus k fy 0 0 divided by square root of a square plus k square, this value would be 0. This is I will prove. This is we have to prove actually. This is another method. And since this all value are 0, so the f of a is k equal to limit a is k tends to 0 0, a is k times a square minus k square divided by a square plus k square divided by square root of a square plus k square. And this is equal to limit a is k tends to 0 0, a is cube k minus a is k cube divided by a is square plus k square to the power 3/2 and put a is equal to r cos theta and k equal to r sin theta, then a is square plus k square would be r square. Just put this is, then this value would be r to the power 4, here r cube times r, so r to the power 4 would be common, cos cube theta sin theta minus cos theta sin cube theta, and here would be r square times 3/2 and this value would be cancelled. So this is here r cube, here would be r cube, and from here this value is r. So this value is limit r goes to 0, r times cos cube theta sin theta minus cos theta sin theta. Since this is for r goes to 0, so this value goes to 0. So since here I have got this expression equal to 0, so similarly f is differentiable. That means this is one method and this is another method. You can choose any method to find the differentiability. Okay? Oh well. That means if a function is differentiable, this is one method, this is one method. Okay? That means here if we can write from here, if we apply this method, then f of a plus a is comma b plus k minus f of ab minus a is f of x at the point ab minus k f of y at the point ab, if this as right as a is phi 1 a is k plus k phi 2 a is k, where limit a is k goes to 0, this phi 1 a is k and phi 2 a is k always this value is equal to 0. Or if we write this phi a is phi 1 a is k, a is phi 2 k plus k phi 2 a is k such type, square root of a is square plus k square phi 3 a is k, where limit a is k tends to 0, 0, phi 3 a is k equal to 0. Then also this is differentiable. That means this is one method. If we write as a is phi 1 a is k, if we write this expression as a is phi 1 a is k plus k phi 2 a is k, this is where phi 1 phi 2 be limit phi 1 phi 2 is equal to 0 as a is k tends to 0, this is one method. Another method is equal to square root of a is square plus k square phi 3 a is k, where limit a is k tends to 0, this phi 3 a is k equal to 0. This is another method of differentiability. Question: f defined from R2 to R, defined as f of xy equal to xy divided by modulus of x. If x not equal to 0, this is defined, and elsewhere the value of fxy is 0. At first, I will see f is continuous at the point 0, 0. For this, consider x equal to r cos theta, y equal to r sin theta. Then limit r tends to 0 and theta tends to 0. This value would be, just put here, r square cos theta sin theta divided by r cos theta. So this value would be, just cancel r square, limit r goes to 0, theta goes to 0, this value would be r sin theta, and as r goes to 0, this value tends to 0. So f is continuous at 0, 0. Is f is differentiable? Fourth, both partial derivative f exist. For this, fx at the point 0, 0 limit h goes to 0, f of h0 minus f of 0 divided by h, and f of h0 would be 0. So this value limit h goes to 0, 0 minus 0 over 0, this value equal to 0. Similarly, fy at the point 0, 0, this value would be 0. So both first order partial derivative of exist at the point 0, 0. Now to find differentiability, this value would be f of a, here ab is 0, 0, that means f of hk minus f of 0, 0 equal to a is fx at the point 0, 0 plus k fy at the point 0, 0 plus phi a is phi 1 xy plus a is phi 2 xy. F of a is k equal to a is k divided by mod h, this value equal to 0, which is, and f of x, f of y both 0. So this value 0 plus 0. A is times, we can write, since phi 1 f of xy equal to xy divided by mod x, so we can write, choose phi 1 equal to a is times mod k divided by mod h, and we can choose phi 2 equal to, here k times a is modulo h. Then we have to check phi 1 and phi 2 both goes to 0 as hk tends to 0, 0. Obviously this is the phi 1. Phi 1 goes to 0 as hk goes to 0, 0. But phi 2 here a is modulo h, which does not exist when hk tends to 0, 0. This limit does not exist because when hk tends to plus 0 plus, then this value is plus 1. When hk tends to minus 0 plus 0 minus, then this value would be minus 1. So since this limit phi 2 does not converges to 0, 0, so we can tell f is not differentiable at the point 0, 0. So option 3 is a wrong option. I hope my all viewers have understood. This is okay. Well, next question, fxy equal to xy divided by square root of x square plus y square, when x square plus y square not equal to 0 and 0 is elsewhere. First option, fxy is continuous. At first check fxy is continuous at the point 0, 0. For continuity, absolute value of fxy minus 0 equal to absolute value of xy divided by square root of x square plus y square, which is equal to mod x times mod y divided by square root of x square plus y square. And we know mod x less than equal to square root of x square plus y square. Therefore, mod x divided by square root of x square plus y square less than equal to 1. Therefore, fxy minus 0 less than equal to y, and take delta equal to epsilon over 0 plus 1. Therefore, fxy minus 0, 0, 0 less than epsilon. Whenever mod x less than 0 less than x mod x less than delta and 0 less than mod y less than delta. Therefore, limit xy goes to 0 0 fxy equal to 0, which is equal to also f of 0 0. So function is continuous. Next, fxy is differentiability. For differentiability, at first consider the partial derivative with respect to x at the point 0 0. This value would be limit h tends to 0 f of 0 plus h comma 0 minus f of 0 0 divided by h. And this value f of 0 plus h comma 0, this value would be 0 if we put, that means this value would be limit h goes to 0, 0 minus 0 over h, this value would be 0. Similarly, f of y at the point 0 0 is equal to 0. Now, which rules we will apply? If we apply f of a plus a comma b plus k for differentiability minus f of ab minus h fx ab minus k fy ab, here this value is 0. If this expression can write h times phi 1 hk plus k times phi 2 hk, where phi 1 hk and phi 2 hk as hk tends to 0 0 equal to 0, or it can be write as square root of h square plus k square. This expression write as square root of h square plus k square phi 3 hk. For this here f of hk means hk divided by square root of h square plus k square, f of minus f of 0 0 all part f of 0 0 0, f of x at the point 0 0 is 0, f of y at the point 0 0 is 0 equal to, if we write this as h square plus k square, phi 3 is such type hk divided by h square plus k square. Now we have to prove if this is the phi 3 hk, we have to prove as hk tends to 0 0, this phi 3 hk equal to 0. Here this is equal to phi 3 hk equal to hk divided by h square plus k square. Here we have to prove this is as hk tends to 0 0, this value goes to 0. If we put for limit, for finding limit, if we put h equal to mk, then I will get phi mk comma k. If we put h equal to mk, this value would be mk square divided by k square times 1 plus m square, which is depend on the value of m. Therefore, limit hk tends to 0 0, phi hk, this value does not exist since this value depend on m. So fxy is differentiable, this is wrong option. Removal, discontinuity, this is also wrong option. Only fxy is continuous at the point 0 0. Today I will stop here. In my next video, I will discuss some question based on differentiability, directional derivative, which had come in different type of competitive exam. Okay, but at first I will highly recommend that you please see today's video with pay attention. If you have any queries about my channel, about this topic, please do comments in comments box. Okay, and if you don't subscribe my channel, please do subscribe my channel so that you will get all my new video. Okay, see you soon. Stay safe and stay positive always. Thank you so much.